Okay, so in the first few examples, we actually we did some scatter plots and we used the Excel kind of trend fitting tool, and we fitted some nonlinear regressions. Now we can actually model these, and then kind of using standard Excel formulas, and then we can actually use the actual Excel data analysis toolpack regression tool. The advantage of doing this is we get some more detailed information that we wouldn't get from the trendline tool. So imagine that we have a beverage company and we tend to sell more of our product in hot weather. And we want to know if the relationship between temperature and sales is going to be linear or if it's going to be quadratic. So I mean, we could actually use the kind of the trend tool, but we could actually kind of just check it out on our own. So let's before we do any regression model, let's just do a quick scatter plot. So we have the temperature, we have the sales. Just right click on that, format axis. As we're not going to sell any of our beverages when it's like 0 degrees Fahrenheit. So our lowest day was in the 70s. And there we get kind of, temperature and sales. This doesn't look quite linear to me. So as I said, we could kind of, we could fit a trend line. You see the linear doesn't look quite right. We could do a polynomial. That looks a little bit better. So we could play around a little bit with that. Let's just hide it out of the way. But looking at that, we think, hey, maybe we have a quadratic trend. But we want to find some more information about this. So the first thing we want to do is let's insert shift cells to the right. And we want a temperature to the power of 2, i.e. a square temperature if we're thinking about a quadratic. So here we go. And it really is just the temperature squared. And just drop down. Okay, perfect. So now we're going to first have a model. We're going to do the linear to sales related to temperature, and then we're going to see if adding the squared temperature improves our model. So data analysis, regression. So input is going to be A3 to A24, which is correct. And then the sales are going to be in the Y. We'll stick it. E2 actually looks okay as a place to put my regression. We're going to have residual plots, nothing else. So let's just click OK. And as before, our graph kind of started at 0. Let's just format axis and change this to 70. And you can see the residuals here. It's interesting. As the temperature increases, it doesn't look very, it looks like some sort of lack of independence here, or maybe autocorrelation. You see we have high, goes lower, 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 then higher, 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 higher. So there seems to be kind of a non-random pattern here, which again, violates the assumptions of regression. So looking at this, the R squared is about 0.85. So it looks a reasonable model, but as I just mentioned, the residuals look a little bit kind of, they don't look like they're independent, which could indicate it's not a linear model. So let's just move this down here and let's make it a little bit smaller. And then we'll do the side-by-side comparison. And this is probably too big. This is just our initial plot. Okay, so now let's build it again, but include the quadratic term. So data analysis, regression. Okay, the inputs for the X. Okay, I don't know quite what happened there. Inputs for the X are there. Why we need to be on the, say it's on the same sheet. And I'm going to put the output here so we can do side by side. Okay, so we see that the R squared has moved from about 85 to 95. Even with the extra even with the extra term, the adjusted R squared is still much higher. That maybe thinks it's a better model. And again, this is not standard. Most kind of regression outputs, it would show you um, your predicted Y based on the x's and the residuals. It's quite hard to get any patterns when it's broken out into two different graphs. But let's just kind of have a little look at our residuals. So let's just format axis. We're going to change this to, we'll do the temperature first. So we'll start with 70. And you see there doesn't seem to be, it seems a little bit more random here. And even though there's maybe a little bit of heteroscedasticity, as you can see, the residuals get larger as the temperature gets larger. So we may actually want to look at a log model as well. So let's look at the format axis here. And the squared start around 5,000. And similar here, we don't get that kind of weird kind of non-independent pattern that we had before. Okay, and again, so the R squared's much better. And here you can see it's almost that the temperature squared is positive and the temperature is negative. And together they give this kind of almost this takeoff here of sales as temperatures gets very, very high. You get almost exponential sales as temperature gets high. I'm not sure. I think this is just an illustrative example from the book of how quadratic functions work. I'm not sure if this would actually be the same in real life business practice. So just to summarize, we looked at incorporating our squared terms in our model. So we previously had this model like sales equals B0, beta 0, we'll have to just put B for the moment, plus beta 1 times temperature. But now we actually look at this more complicated model that also has squared temperature, and we find a much better fit that fits the shape of the graph much better. So that'll be B2 times temperature squared. Okay, and that's just writing it longhand. Okay, so that's the last exercise for this regression chapter.